Didn't see you there. Welcome back to our asynchronous learning series. Today we are going to continue talking about right triangle trigonometry. Given a right triangle, we know that the sides are often labeled as A, B, C. I want you to notice that the sides are lowercase and that the angles opposite those sides are uppercase. So angle A is opposite side A, angle B is opposite side B. This would be angle C. It's our right angle today. I want to review real quick solving right triangles. So let's suppose we have this triangle and I knew that side B was actually 5 and angle B was 20 degrees. And I wanted to solve the rest of this triangle. There are a multitude of ways to do it, but to keep this clear and quick, I'm going to use some specific ways just to show you the trig stuff. We know from what we've learned before about right triangles, from this angle theta, right 5 would be the opposite side, this would be the adjacent side, and then C would be the hypotenuse. So if I'm trying to solve side C, the hypotenuse, I already know the opposite. I need to figure out which ratio uses opposite and hypotenuse. And again, a little review for you. You may or may not remember SOHCAHTOA. It's a mnemonic device to help us know whether we should use sine, cosine, or tangent. Since we're working with opposite and hypotenuse, we are going to use sine. So to solve for, let's write it here, to solve for C, we're going to use sine, and it's going to look like this. We'll have the sine of 20 degrees is equal to opposite 5 over C. You might want to take a minute to pause and see if you can solve that yourself. The way I like to approach these problems is I like to first figure out what is the sine of 20 degrees, making sure your calculator is in degrees, whether you're on your phone or finding a calculator online. We end up getting that the sine of 20 degrees is 0.342 equals 5 over C. And the way I solve that, I like to multiply both sides by C to show actually what is happening with those C's canceling out. And then I would divide at the end by, so we'd have C times 0.342 equals 5. So then, of course, my last step is going to be to divide both sides by 0.342. This is the hardest version of solving trig problems because the unknown is on the bottom, right? So we're kind of starting off with the hardest one. And I would get that C is going to be, not that I know it in my head, but I just remember from before, 14.62. Okay, so C is 14.62, so I'm going to come up here and replace that. Say we have found this side to be 14.62. Again, hopefully a refresher of some trig you've learned before. Like I said, when the unknown is on the bottom, that's the trickiest problem we can have. I'm actually going to do this with, I'm going to do another trig problem, but this time I'm going to be looking for A. So I'm going to do a little bit of the easier version. Here, I'm going to use, we could do a bunch of things, right? You could maybe use Pythagorean theorem if you're paying attention. I'm just going to go ahead and show us, for the sake of notes, another way that we would solve trig problems. And usually the most basic way you would do it. I'm going to work with the side we just found, the hypotenuse, and I need to know the adjacent side. So looking for adjacent and hypotenuse tells me I need to use cosine. So this time my equation setup would be that the cosine of 20 degrees is equal to adjacent, or 14.62. And this is a little bit of the easier version because the unknown is in the numerator. So here, all I need to do is multiply both sides by 14.62. And then those guys, of course, simplify to 1 or cancel out. And that's it. As long as we can type that into a calculator, I get that my A value is 13.74. And I'm done. Okay. So this would be 13.74. Now, the only other one I'm going to show you, just because it's going to come up and it will test our accuracy, is how do I find angle A? Now, I hope in real life you wouldn't use trig to find angle A, right? Because if this is 90 degrees and this is 20 degrees, the sum of a triangle has to be 180. We automatically know that A is 70 degrees, right? So keep that in your head. You know A is 70 already. But in the name of reviewing our trig functions, I'm going to find A anyway. So in order to solve for angle A, I'm going to use the trig approach because you might have to in future problems. And as a review, so here working with solving angle A, notice now from A, not the adjacent side. This is not adjacent to A anymore. Actually, what my problem is going to look like now, just to redraw, if I want to know that angle, and this is 5, and this is 13.75, or 74, these switch, right? Opposite and adjacent are relative terms to which angle I'm starting from. Since I'm now starting from that angle, 13 is the opposite side, 5 is the adjacent side. Okay? So, working with opposite and adjacent, look at that. We've tucked in all 3 trig ratios. I would set this up as tangent of theta, or A in this situation, of my angle is equal to 13.74 divided by 5. So I get that the tangent of A is 2.748. And this is the part where you may or may not remember. To solve for an angle is when we use inverse trig. So right here, technically what you're doing is you're technically still doing a thing to both sides, right? I could still write this as tan inverse of that side. Some people don't ever see that notation, that you're taking the tan inverse of both sides, but I really would end up writing it out as the angle is equal to tan inverse of 2.748, which we already knew, but just good to check, is 70 degrees. So what I want you to make sure is that you can use a calculator to get all of these numbers, and then here's your asynchronous problem for the week. All right, so this is your asynchronous problem for today. I want you to completely solve this triangle. That is, find all missing sides, find all missing angles. If you have any questions, as always, you can come to office hours, you can let me know on Remind, email, whatever. I really look forward to seeing your work. You will make sure this is hand-drawn. I want to see your work and the trig ratios that you use. Good luck.